Hi, my name is Katie and welcome back to my channel. So today in class we learn chapter 15 and I will only be doing chapter 15 part 1. Part 2 will be done tomorrow. So basically in this chapter we are working with data. So basically over here we are generating data and I've done a few try it yourself activities which I will be explaining and displaying how the code works. So we've got our first question, which is 15.1 cubes. A number raised to the third power is a cube. Plot the first 5 cubic numbers and then plot the first 5,000 cubic numbers. Okay, so we've got our x values. So this holds the numbers from 1 to 5, and then we've got our cubes. It contains the corresponding cubes like 1 cube is equal to 1.2 cubes and then equal to 8 and so on. And then we've got the Seaborn V0 underscore V8 over here. And it is basically applied to style the, the graph for a more modern and neat look. And then we've got creating the plot. So when we look at these two lines over here, line 11 and line 12. So on line 12, line 11, is it line 11? Yes, it's line 11. So this basically sets up the figure in the axis for plotting, and then on line 12, this plots the points with the size of 40. And then we've got the labels and titles. So the titles and the axis and the labels, so for example, value and cube of value are added to describe the plot, and then we've got the font size. I'm explaining here. So this customizes the size of the text for better visuals. And then over here on line 20, that line of code adjusts the size of the tick labels and improves it for clarity. And then lastly, we've got the plot shows that also display the graph bar. So let me just show you real quick. As we can see, here is the dots plotted, and here's our cube values. Everything works. Okay. Now, let me just see where it is. Okay, yeah, we will be plotting the 5,000 cubes. So basically, we've got the data set up. So the x values includes integers from 1 to 5,000, and then the y values computes the cubes for each value in the x values like x cubed. And then we've got the color and style over here. Let me just get it for you. Yeah, on line 36. So basically, those points are colored based on the value. So for the y values, we have the blue color map. And then the S10 at the end ensures that the smaller point sizes since there are many data points. And then we've got the plot customization. So the title cubes and the axis label value and cube of value that clarifies the graph. And then we've got the tick label sizes, which is adjusted for readability. And then we've got the plot show that will display the graph for us and its visuals. So let's run that. As we can see, here it's the 5,000 and then here's cubes. So everything works. Cool. And then moving on, we've got 15.2. Let's just go to the question. So basically, apply a color map to your cube plots. Okay. So here we've got the x values. It holds the number from 1 to 5,000 and the y values of the cubes. So basically, the plotting is used with this color, the blues, on line 59. So this is plotted with a blue gradient, and we've got the labels and titles. So this is just the same code, but some of there is a few changes here which I will be explaining. So the labels and titles is a title cubes, and then the X's labels explains the graph, and then lastly we've got the plot show. So when I run this over here, this is our graph. As we can see the blue over there. Moving on. So now we've got 15.3, and basically molecular motion. So modify RW visual py by replacing the x getter with x plot to stimulate the path of a pollen grain in the surface of a drop water pass in the RWX values and the RWY values, and then include a line worth argument using 5,000 instead of 50,000 points to keep the plot from being too busy. Okay, so yeah, the curve visualizes a random walk with 5,000 points. So the random walk generates and fills the walk's coordinates. And then we've got the plotting, it uses the AX plot. Um, over here. And it highlights the starting point green and then the end point red with larger markers. And then the axis hides the X and Y axis from for a cleaner look. And then we've got the display code over here, the PLP show. And then over here, we've got the initialization that starts at 0 with lists of X values and Y values to track positions. And we've got default walk length is 5,000 points. And then we've got the random step using choice 1 and -1 to pick a direction, left, right, up, or down. And it uses choice 0, 1, 2, 3, 4 for step size, and then combines the X step and Y step for each movement. And then we've got the skip sets with no movement for both X and Y steps are 0 over here. And then we've got our new position. So it updates the position by adding steps to the previous coordinates and then repeats it until the steps have reached 5,000 points. So let me just display this for you. I'm supposed to display it over here. As we can see, we've got our X and Y values at the bottom of the grid. And there's the red marker, and there's the green marker. Cool. And then we've got 15.4, mo modified random walks. So in the random walk class, X step and Y step are generated from the same set of conditions. The direction is chosen randomly from the list 1 and -1, and the distance from the list is 0, 1, 2, 3, 4. Modify the values in this list to see what happens to the overall shape of your walk. Straight a longer list of choices in the distance such as 0 to 8, or remove the negative one from x or y directions list. Okay, so here we've got our initialization, and the walk starts at 0, as you can see, and then the x values and the y values store the parts of the coordinates, and then we've got the num underscore points, and then determines the number of steps, so the default is 5,000 basically. And then we've got the random step generation fill underscore walk method on line 42. So basically, for each step, randomly choose a direction of 1 or negative 1 for both x and y. Randomly pick a distance, example 0 to 8, and then multiply the direction and the distance to get x step and y step. Skip steps that don't move when both steps are 0. And then we've got updating the position, and this adds each step to the last position. And then we've got the append, new position, the x values and the y values. And then we've got the random walk class on line 47. So this generates 5,000 random points in the x values and the y values, and then we've got the plot. This connects the points with the AX plot to show the path, and then the highlight here, it marks the starting point green and then the end point red. The axis removed, so it hides the x and y axis for a cleaner look. And then we've got our display code over there. So let me just run this for you. Moving on, just going to display the graph. As we can see, here's our green and then there's our red. And then obviously it starts at our axis is at -1. Let me just get that number for you. Where did I get it? Okay, I can't get -1. It's really tricky. But basically the graph works and it's good. And then moving on, we've got 15.5. Refactoring. The for walk method is lengthy. Create a new method called getStep to determine the direction and the distance for each step, and then calculate the step. You should end up with two calls, getStep and fill in walk. So we've got 15.5, and basically the start is at 0 for the x values and the y values, and then it holds the coordinates, and then it starts at the origin. And then we've got for walk method. So this adds a random step x to the x step and the y step until 5,000 points are reached, and then skips steps with no movement. And then we've got this get step method, and this randomly picks a direction between 1 or -1 in the distance of 0 and 4 to create a single step. And then go to the next file. Over here, we generate the walk. So let's create a walk with 5,000 points using the random walk class, and then it calculates the path x and y coordinates, and then for the ax plot that connects the points to show the path, and then highlights the start point green and then the end point red, and then we've got the style and display, so that it removes the x and y axis from for a cleaner look, and then the display graph with this line of code over here. So let me just run this. Why doesn't it? As we can see, there is the green and then there is the red. And that is it for chapter 15, part 1. Thank you for watching.